In this video, we're going to take a look at solving quadratic simultaneous equations algebraically. Now, the way that we do this here with an algebraic method is by using substitution. And you might remember that we could also use this method here for solving linear simultaneous equations, and we could do that using substitution as well. So I think for this kind of topic here, let's just run through one example and explain it as we go. So to begin with here, we're asked to solve the simultaneous equation. So I've got x squared plus y squared equals 5. And x equal to y plus 1. So basically what you've got here, if you remember from the previous video, is the equation of a circle. So we just think about sketching this here. My x-axis, this is my y-axis here. Basically what I've got here is the equation of a circle that's centered at the origin, so 0, 0. It might look, say, something like that. It won't look quite like that, but you get the idea. And this here is the equation of a straight line. It's not quite in the correct form. Remember, for the equation of a straight line, we normally write it in the form y is equal to mx plus c, okay? But this here is the equation of a straight line. So it might look, say, something like that, okay? And from here, we have two solutions. So if I just mark these in a different color, do it in orange. Got one solution here. So basically what we're looking for is where the straight line intersects with the circle. And I have a solution here. Okay, so what I'm going to do now is take this equation here for my straight line. I'm going to rearrange it so that either x is the subject or y is the subject. And like you can see for this question here, x is already the subject, so we don't need to do that. But often the case is that you will need to rearrange it to make either x the subject or y the subject. What I'm going to do then is substitute that equation into the equation of a circle. Okay, so like we said, I'm going to label this here equation 1, this here equation 2. However, in this case, equation 2 already has x as a subject, so we don't need to rearrange that. But what I can do now is substitute x equals y plus 1 into equation 1. Okay? Like so. So, in that case then, x squared here, that's going to be y plus 1 squared. Like so, plus y squared is equal to 5. And what this does here now is it eliminates x from this equation 1. Okay, so equation 1 now is just in terms of y only. So I've got y plus 1 squared. So this is just double brackets here. So expanding double brackets, y plus 1 times y plus 1. If you expand this here, you get y squared. We get y squared. Y times 1, so that's 1y, or just y. And again, 1 times y would simply give me y. So y plus y would give me 2y. We get plus 2y. And then 1 times 1 would give me 1. We then move on to the y squared here. And that is equal to 5. So from here, what I'm going to do now is simplify the left-hand side here. Okay, I'm going to collect like terms. So y squared plus y squared. That gives me 2y squared. We've also got 2y here. I've got 1. And what I'm going to do then, so if I just write the 1 here, so let's do it step by step, just so we don't cause any confusion. This is all equal to 5. But remember, when we're solving quadratic equations like this, what I want to do is set this quadratic equation equal to 0. I'm now going to subtract 5 off both sides. And what that will do here, it will make the right hand side equal to 0. So 1 minus 5, that would be minus 4. We get 2y squared plus 2y. And then 1 minus 5, like we said, that would give me minus 4. That's equal to 0. So from here, it's up to you now. There's two ways of tackling this. We can either go straight into factorizing, or what you might notice here is everything is a multiple of 2. So 2y squared, 2y, minus 4. What I can do then is divide through by 2 because everything is a multiple of 2. Okay, so dividing through by 2, I get y squared plus y and then minus 2. That's going to be equal to 0 divided by 2, which is 0. So from here, what I want to do now is check whether this quadratic equation factorizes. And generally speaking, for these type of questions, it will factorize. And in this case, it does factorize here. We're putting this now into double brackets here. This in terms of y, so we get a y at the front of both of these brackets, like so. So two numbers now that will times to give me -2, add to give me +1 here. So that would be +2 and -1 there, okay? So 2 times -1 is -2, 2 plus -1 gives me +1, okay? So that's perfect. So from here now we can identify the two y solutions. So we go back to the top here. So y plus 2 equals 0. That would mean that y is equal to -2. Y is equal to -2. And my other solution here is when y minus 1 equals 0, giving me y equals 1. Okay? So what we've got here is the y solutions. If you think about the diagram here, what I've got now is the y solutions to these 2 points, but what we also need is the respective x solutions, okay, the x coordinate for those points. And to find those points here, what I'm going to do then is take my values of y here, and substitute those now back into equation 2. So x is equal to y plus 1. So in this case then, when y is equal to -2, we know that x is equal to y plus 1. So x is equal to y, which is -2 plus 1. -2 plus 1 would give me -1 there. Okay. Doing the same now when y equals 1 here. When y equals 1, we get that x is equal to y plus 1 here. So in that case then, y plus 1, that's going to be 1 plus 1, giving me 2 there. Okay. So to finish with then, if we write the solutions here at the bottom, and if I just do these in a different color just to make it clear, my two solutions then are x equals -1 and -2 here. So the x solution is -1, and with that x solution then we get y equals -2. And then we've also got x equals +2 here, and when x is equal to 2, y is equal to 1. Okay. And there we have it. So that would be the solution there to question 1. Moving on to question 2 now, we're asked to solve the following simultaneous equations algebraically. So to begin with here, what I'm going to do is I'm going to label the first equation here as equation 1 and the second equation here as equation 2. Okay. Now, if we're going to solve these quadratic simultaneous equations here algebraically, then what we need to do is use substitution. So I'm going to take my equation 2 here, the second equation, and what I'm going to do is I'm going to make either x the subject or y the subject. Now it doesn't matter which you make the subject, whether you make x the subject or y the subject, as long as you substitute in correctly and simplify and then solve correctly, you'll get the same solution either way. Okay. But in this case, what I'm going to do then is make y the subject here. So if I make y the subject here, I just simply need to add x to both sides then. So we get that y is equal to x plus 3 there. Okay. So what I'm going to do now is actually use substitution here. I'm going to take this value of y here, or this expression for y, x plus 3, and substitute that into my y here. So this y squared, we take this y here, and we substitute that into equation 1. Okay. So I do that underneath here then. We're going to get x squared. Y squared here, so y is x plus 3, so that's x plus 3 squared, like so, and that's equal to 17. And basically what this does here is it eliminates y now in equation 1, and what we can do then is go on to solve for x. Okay, so if we expand this bracket here, so we've still got the x squared here at the front. Expanding this bracket here, this is just a product now of 2 brackets, so we're just expanding double brackets. So I've got x plus 3 times x plus 3 here. So just expand using FOIL or any method that you're familiar with. So I'm going to get x squared. We get plus x squared. We then get x times 3, which is 3x. And then again here, 3 times x, which is also 3x. So 3x plus 3x, that will give me 6x. We get plus 6x there. And then finally, 3 times 3 is 9. we get plus 9, and that's equal to 17. So if we just collect like terms here on the left-hand side, I'm going to get x squared plus x squared, so that's 2x squared. I've then got plus 6x plus 9, and that's all equal to 17. Now from here, when we're solving a quadratic equation like this here, remember, we always want to set this equal to 0. But what I'm going to do now is subtract 17 off both sides here. That will mean that my right-hand side now becomes 0. So minus 17 off both sides. Minus 17 off both sides. So on the left-hand side here, we're going to get 2x squared. We get 2x squared plus 6x, that doesn't change. And then 9 minus 17, and that will give me minus 8 there. Get minus 8, and that is now equal to 0. Now from here, you have two choices. I can either go straight into factorizing here, or what you might notice is everything here is a multiple of 2. I can divide through by 2 then. If I divide through by 2, divide through by 2, do the same here on this side, I'm going to get x squared plus 3x. We get x squared plus 3x, and then minus 8 divided by 2, that will give me minus 4, and that's going to be equal to 0 divided by 2, so again, that will be 0. Now from here, what I'm going to do now is try and attempt to factorize this. Sometimes it might not factorize, but generally speaking, because it's already quite a tricky topic, the quadratic that you obtain will generally speaking factorize. So if I attempt to factorize this here, we'll get 2 brackets equal to 0. I'll have an x at the front of both of these brackets here, like so. So two numbers now that will multiply to give me minus 4, but add to give me positive 3 here. That would be plus 4 and minus 1 there. Okay. In this case then, this will give me two solutions here for x. We get that x equal to positive 1 and minus 4. So we'll do it in order. So x plus 4, first that's minus 4. We also have that x equal to positive 1. Okay. So x equal to 1 and x equal to minus 4. So we've got the x solutions here, but don't forget we also need the respective y solutions. So go all the way back now to the beginning of the question here. We're now going to substitute these values into either of these equations here. But really, it makes sense to just substitute this now into equation 2. We've already got it in the form here that y is equal to x plus 3. If we just substitute these x values in, we simply get our y value as well. So when x equals minus 4, when x equal to minus 4, y is equal to x plus 3. So that's minus 4 plus 3. So minus 4 plus 3, that will give me minus 1. That's the y solution there. And then when x is equal to 1 here, when x is equal to 1, y is equal to x plus 3. So if x is 1, 1 plus 3, giving me 4 there. Okay. So the solutions here, you get that x is equal to minus 4 and x equals 1. My y solutions here, so the respective y solutions, when x is minus 4, y is minus 1. Then when x is equal to 1 here, so that shouldn't be an x, that should be a y. We nearly got through without making a mistake. So y is equal here to 4 then. Okay, so when x is 1, y is equal to 4 there. Okay, and there we have it. So that's the solution to question 2. And finally, to finish with now, if we take a look at the very last question, we're asked to solve the following simultaneous equation. So I've got x squared plus y squared equals 10. Let's label that as equation 1. Then we've got x minus y is equal to minus 2. And let's label that as equation 2 here. So to begin with here, what I'm going to do then is rearrange equation 2 so that either x is the subject or y is the subject. In this case, I think it's easiest if we just make x a subject here. So to do that, we're just simply going to add y to both sides. So x is going to be equal to y minus 2 there. And what I'm going to do now is substitute x here into equation 1. Okay. We get x squared, so that's going to be y minus 2 squared plus y squared is equal to 10. So now what I need to do is expand these double brackets here. Don't forget that's simply y minus 2 times y minus 2. So expanding these here, I'm going to get y times y, which is y squared. I've got y times minus 2. That will give me minus 2y. And then again, I've also got minus 2 times y. So again, I'm going to get minus 2y. So minus 2y minus another 2y. That will give me minus 4y. And then finally, minus 2 times minus 2. Just be very careful with the signs there. That will give you positive 4. Okay, so we get plus 4. Don't forget the plus y squared here. And that is equal to 10. So if we simplify the left-hand side here, we get y squared plus y squared. So that's 2y squared. I've then got minus 4y. And I've got plus 4 here. And that's all equal to 10. Okay. So just like we did for the previous two questions now, what I want to do is set my quadratic equation here equal to 0. So if we subtract 10 off both sides now, that will mean that my right hand side here is now equal to 0. So on the left hand side, we're going to get 2y squared minus 4y. And then 4 minus 10, that will give me minus 6. That's going to be equal to 0. So again, from here now, we can either go straight into factorising or attempting to factorise. Or if you notice here, everything is a multiple of 2 again, you can just divide through by 2. So dividing through by 2 and dividing through by 2 here. What I get then is y squared. Minus 4y divided by 2, that will give me minus 2y. And minus 6 divided by 2, that will give me minus 3. And that is equal to 0 here. So now what we want to do here is attempt to factorise, and in this case, this does factorise. We're going to get two brackets here, which are equal to 0. So this in terms of y here, so we're going to get a y at the front of both of these brackets. So now we need two numbers that will times give me minus 3, add to give me minus 2 here. Well, that must be minus 3 and plus 1 there. Okay. So in that case, then we get two y solutions here. When y minus 3 equals 0, we get that y is equal to 3. And when y plus 1 equals 0, we get that y is equal to minus 1. So we've got the y solutions here. Don't forget we now need the respective x solutions here. And we can simply obtain those by now substituting these y values back into equation 2 here, or our rearranged form for equation 2. So when y is equal to 3 here, then x is equal to y minus 2. So 3 minus 2, which would give me 1. And then we just repeat this here when y is equal to minus 1. When y is equal to minus 1, and x is equal to y minus 2. So minus 1, minus 2 there, giving me minus 3. Okay. So if we just put the solutions together now at the bottom, so when x is 1, y is 3, x equals 1, y is equal to 3, and when x is equal to minus 3, y is equal to minus 1 there. Okay, and there we have it. So let's just highlight that. There we go. So there we have it. So that's the solution to question 3, the very last question. And that actually brings the end of this video on solving quadratic simultaneous equations algebraically. So in the next video, we're going to take a look at exam revision for quadratic simultaneous equations.